First, I introduce this round journey. Welcome, Professor Li come from Zhongzheng University. Professor Bai come from Taiwan University. Professor Bao come from National Zhongzheng University. Professor Jiang come from National Taiwan Normal University. Please introduce your team. Report.
I'm the captain of Team CDP. I'm Hong Yujie, and this is Cai Yilei, Ji Yaxing, Lin Pingyi, and Wang Yanqi. Thank you.
Opponent.
Hello everyone, we are from Team S601. My name is Wu Xiaoqi, and she is Guo Zilin, Zhang Yunjun, Lai Huiru, and Lai Qingxi. Thank you.
For reviewers.
Hello everyone, we're Team Albas from Xinjiang High School, and this is Ye Chenyu, Wang Yanzhen, and Ji Kaiting, Zhang Yunzhen, Xie Zhenxi.
Thank you. Now for your challenge, please.
We want to challenge your problem number 5, income graphic.
Reporter number 5, okay?
Can we discuss? Can we discuss? Yeah, 1 minute. Okay, sorry, we accept.
Please write down your
第3个冒号上面，就是色条下面。
Report, please.
Distinguished judges and fellow competitors, this is Team PTP, and I'm going to report question number 5, ping pong racket. So here's the problem statement. A ping pong ball is placed in a container of water. When the container is dropped, the ping pong ball will get launched to a great height. What maximum height can you reach up to 2 liters of water? And here's a few factors we can consider. First is a contact mechanism, and the second is buoyancy. Here's my presentation outline. First is the observation, theory, experiment, set, design, result, conclusion, and future experience. And here's the observation video. So we can see that when the container dropped, the ball will bounce out of the container, and we want to measure the maximum height of the ball. And here's a few disadvantages of my observation. I found out that there will be a substantial division in the descent trajectory. And the second is that the ball will adhere to the cup wall, thereby affecting the rebound trajectory. And here's my theory. We think that the meniscus velocity will give the rebound force up to the ball. Because when we observe the ball in the water, we can see that there's a meniscus deviation of the ball. And therefore, the balls will have a volume that's in the water. And so we think that the water will give a force to let the ball bounce out to the water from the container. And here's the theory. We think that the deformation of the water is the velocity field, and that gives the propulsion of the ball. And the second theory is that we think that the impact force will transform the ball from bouncing out the container. And I've mentioned that we have two factors to consider, right? So the second factor is buoyancy, but we have found out that when the ball is dropping, the acceleration will almost equal to the G force. So we think that the buoyancy is slight enough to be ignored. So when the buoyancy is light enough to be ignored, the ball can easily sink into the water. Therefore the ball can bounce out to from the container. And the second things we guess to consider is the value of little r divided to big R. We think that we want to find out whether the radius of the container bigger, the ball will bounce higher, or the radius of the container is smaller, the ball will bounce higher. And this is my guess from the beginning. I think that the impact force will give the force that the ball bounces out to the water, and there will be a slightly energy dissipation, and the ball will get bounced out by the impact force. And also the meniscus cave will be the velocity ball. And this is my experimental setup. At first, because there are two disadvantages from the beginning that I have found out. So in order to break the barriers, I have made this system at the beginning. And this system is without stick. But we found that when we use this system without stick, won't be straight. So we add up 2 sticks in the end. Also, we use 4 fishing lines to make sure the trajectory will be straight. And secondly, to ensure the ball will stay in the middle of the container, we use the plastic to give the ball a place that will make it stay in the middle. And here's my experimental result. We found that when it's 200 milliliters, it will bounce out to about 100 and more centimeters. So we can give it a graph like this. And in my guess, I think that it will have a logarithmic plot, and the equation will be like this. But this is only in my guess. So I'll give it the answer that when it's 2 liters, the ball will bounce out to 523 centimeters. And here's my experiment result. So when I drop off the container, the ball will bounce out. It's too small to be seen, but the ball will bounce out to this place, and it's about 4 meters. And also 600 mole and 200 mole. You can see that the ball will bounce to this place, and the balls will bounce to this place. So we can see that it's significant to see that the ball will bounce very low at the beginning, but when in the 800 mole, you can see that the ball will bounce up really high. So we can prove that the previous graph, that the rebound height will decrease really significant at the beginning, but become flat at last. So this is my conclusion. I still believe what I guessed in the beginning, that the impact force will affect the ball, and because this is the meniscus deviation, so this will be the velocity center. So when the container is dropped to the ground, because the impact force given the water the force, but the pressure will all go to the velocity hull. So, and because of the energy dissipation, it's not significant enough in the beginning, because the container we use is all the same during the experiment. So the depth will also change when my volume of water change. So when the depth is increasing, the energy dissipation will also increase. So in the end, the energy dissipation will be significant enough to impact the whole system. And that's all my presentation. Thanks for listening.
Question of our opponent.
And so, first I would like to ask, do you control the bucket drop vertically to the ground?
You mean if I'm straight enough?
Yeah.
I'm trying my best to make sure it's straight. So we have made this system, right?
Okay. Do you think that water is a necessary factor in experiments? Necessary what? Factor.
I think yes, because I think the density of the solution will change the impact force.
So do you think if I just put a bucket and a ball, will the ball still launch? Is that
I've
right?
tried it before, like once or two, and the balls didn't bounce out really significantly.
And do you think there are energy loss in this phenomenon?
Yeah. So that's why the graph will be like this.
And like I see that in your result, your ball may bounce. The ball didn't bounce vertically. Do you think that will affect the experiment result?
Yeah, it will it definitely will impact this result, but we are trying our best to make sure it's accurate enough.
Okay. And I see that in your experiment setup, you use 2 sticks to make sure that the container is dropped vertically. Do you think the friction will also become energy loss in this phenomenon?
You mean the friction of the?
Friction between the
Fishing line.
container and the stick you use.
Oh, we use fishing line. I mean,
You use fishing line?
do you want to see that setup?
Yeah. Okay.
So we got 4 fishing lines in the middle, and we use, you know.
Okay, so do you think the tension of the fishing line will affect the result?
No, because it will be really slight because the fishing line is very smooth, right?
Hello everyone, my name is S601 PF4, and today I'm going to oppose problem number 5, ping pong rocket. And here's our problem statement. And about this problem, we will mainly focus on the maximum height the ping pong ball can reach in an experiment, and searching the reason that the ping pong ball lands out the different maximum height. And overview of the report. Their theoretical model, they have minus k velocity, impact for an energy displacement. And we think that consists the lack of the theory to explain how will the water jet affect the experiment result. And about experiment setup, they change water volume. And we think that they have clear explanation of this phenomenon, but the way they release the bucket cannot ensure the bucket is vertically dropped down. And for data analysis, they have put maximum height. And in their process, they found the relationship between water volume and height. But their consists they lack of error bar and lack of theoretical line. For discussing point, I'm going to discuss about pressure wave, force analysis, energy transformation, and elastic collision. And for experiment and setup, I'm going to discuss the water volume, mass of the ball, material of the bucket, and also the ramp. And for data analysis, I'm going to talk about maximum height, error bar, and how to fix the experiment result to the theory. Thank you. And now I would like to ask. energy transformation of the ball and the bucket. But I see that you didn't really draw energy transformation graph in your presentation.
I have drawn the relationship between the forces, but I don't really sure what you want to see the graph.
You can use the blackboard. Okay, so if this is the bucket and this is water, this is the ball. Here draw the potential energy of when it is still at a certain height. You draw the energy transformation of the whole process.
You mean when it's moving or is
No, it's still not moving. It's on the top of the height that we want.
so the water will give it like potential energy, and there is a that is deviation. So we think that the water will give it the force that we want to see on the ball. That's why it's given the beyond.
I think
The
you're
ball.
misunderstanding. I mean, this is the place where we haven't dropped the bucket. Yeah, but I'm thinking if you haven't dropped the bucket, can you explain the energy that it is in this situation? Like maybe the potential energy of the bucket and the water in the ball.
So like the water will give it the buoyancy, so the ball will stay in the middle.
How do you make sure when the water gives the ball buoyancy, the ball will stay in the middle?
Like it's common that when there's volume in the water, it will give the buoyancy that's equal to the density multiple to the
Yeah.
volume. Right. So the ball will get the force of the water and stay there.
So you think as long as the ball is in the water and there are buoyancy to the ball will stay in the middle?
Yeah.
Okay, but I think that even though there are buoyancy to the ball, I think the ball will still be moving because when you're really putting the whole bucket out in the real situation, the bucket will be moving or something. So I don't think the ball will be in the middle just because of buoyancy. And I think that I don't think you understand what I'm going to add. I'm going to add is that because we haven't dropped the bucket at this graph, so I think there will be potential energy here. So I think there will be potential energy equals to all the mass of the container, and the mass of the ball, and also the mass of the water. And times gravity and times the height here. Do you agree?
Yeah, I agree.
Okay, so if you understand me, then you draw the graph of when the whole thing drop at the bottom. How will the energy transform?
You mean when it's free falling?
Yeah, it's free falling.
Okay, so when it's free falling, due to my equation, the buoyancy will be almost equal to 0.
Okay.
Okay, so when it's dropping, because due to the equation, like this. This. So we can see that the acceleration is almost equal to g force.
Yeah.
So the buoyancy is not functioning, and when it's free falling, there haven't been the impact force, right?
Yeah.
So the impact force is the ground.
Okay.
They haven't had the impact force. So there are two systems that is free falling. The ball and the bucket.
Yeah, so I'm asking the energy transformation to it.
There haven't been the energy that's given from the ground.
Yeah, but I think that when it is dropping, I think it is really common to understand that the height is changing, and because it's dropping, we have a velocity to the container and the ball. So I think when it is free dropping, the potential energy will decrease. This thing will decrease because H1 will decrease, but the kinetic energy will increase. And times this whole thing times the velocity of the zero. Do you agree?
Yeah, so we think that the energy from this position will transform into the galactic energy. Right.
Yeah. So Okay, so then after the whole bucket bounce to the floor, do you think there will still be potential energy or the whole thing will change into kinetic energy?
So we think that the energy will transform into the kinetic energy, but there will be the energy dissipation, right? So the energy will lost during the transformation.
Okay, so can you explain which part of energy will lost during the, like which thing will let the energy lost during this phenomenon?
Like the depth of the container, because when it's transformed from the ground, during the transformation, the energy will lost.
So you think that the ground gives the energy to the container, and because when the energy is transforming from the bottom of the container to the top of the container, the energy will lost. And do you think the energy loss has anything to do with the collision between the bucket and the ground?
Yeah, so the graph was like the basic graph, you know.
Okay, so next I want to talk about the part you have the graph that I think it's about the pressure in the water.
Pressure in the water. This one.
No. Yeah, no,
This
yeah,
one.
this one. Can you explain this again? I don't understand why you want to get.
So what I mean is that there will be because the ball is in the water, so the volume will make a meniscus deviation, like this shape.
Okay.
So the water will give in a pressure.
So do you think in this graph, the pressure goes from the bottom to the top, or the pressure is from the top to the bottom?
Like everywhere, like there have a pressure and the water have a pressure.
But this part should be the part where the container is dropping. So when the container is dropping, the surface of the water will have a hole in the surface of water will be like this. So because this part decrease, so the pressure at this part will decrease. And so I think that because this part decreased during the free falling, so after the whole thing dropped at the ground, because the pressure that pressed to the ground and it bounced back, so it will create another pressure. It will have another pressure to push the whole ball up to the air. Do you agree?
Yes, I'm agreeing is that when it hits the ground, the ball will get into the water, right?
Yeah.
It will sink into the water, so it will also make a deviation to the water, and so the pressure will want to push out the ball.
Okay, so if you have noticed this graph, have you found that when you are doing this experiment, they will have a water jet when the container drop?
Oh yes, yes.
And do you think the water jet is the main factor to the ping pong ball?
Right. I think the water jet is the present of the pressure, you know, because we can see the pressure. So I think the water jet is kind of like the present of the pressure.
So you think the water jet presents the pressure, and then the water jet push the ball up? So you think the water jet is the main factor to push the ball up?
I think the impact force and the pressure is the main factor, and then the water jet is just the present of it.
Okay, so I think that because all the pressure here will transfer into the water jet, and so I think that the water jet is the main factor to push the ball up. So this is why I also think that the placement of the ball at first is really important, and whether the bucket is dropped at the ground vertically is also important, because if the bucket is dropped at the ground vertically, the water jet will be in the middle of the whole container. And if you also put the ball in the middle, that will create the maximum height for the ball. I think that is the main reason that how can we get maximum height in this problem. Okay, so I want to see your data part. Yeah, so you say that you only do you only do to 200 milliliters, or you do
200, 400, 800, and 600, and 800.
Okay, so this line is using how well this line is the guess and using how well the data turn into when it goes to 2000. So you really
I did this 4 experiment.
and you use the 4 experiment to guess that to guess. Okay, but do you think that when the 4, although you think that maybe you think it's possible, but maybe when you reach to 2 liters of water, the energy loss will be even bigger. So maybe do you think it will not fit this formula?
Yeah, of course it will be slightly accurate because this is how the experiment goes, right? So I think this might not be that accurate enough, but this will be my guess, and I think it makes sense. So I would say this relation.
Okay, so I want to see the result video. So you can see that every time when you drop the container, you are at different kind of material of ground. So maybe this is in the wood part and this is just normal. And do you think that will affect the result?
Honestly, we don't think it will because we have given space that's between the ground and the wood. We use wood in the bottom.
So can you just turn to the experiment setup?
So it cannot really show, but we have given a little bit of height between it, and the wood is really stiff. So we can kind of make sure like the material is almost the same.
Do you think the wood that you put under is the rigid bottom? You cannot bend the wood.
Yeah,
so
we
you have
cannot.
elastic with the wood you put under.
And so the elastic will be almost the same.
Almost the same, but if they have a elastic, then they will have another force due to the container.
Yeah, but like it's we can pretend it's a ground. It's the same kind of.
You can pretend it's the same kind of. Okay, and to my short question time, I asked that you use the fishing line to drop the container. And I'm asking, do you think the tendency of the rope will affect the result?
I think it's slight enough to do.
So you think?
And it's all every time it's the same.
Okay, so saying it's no.
And it's every time. It's the
Time is
same.
up.
Thank you.
Summarize, please.
So I'm going to summarize for discussion. And for theoretical, for the theory, we talk about the energy transformation of the system. And the water jet is really important to let the ping pong ball launch to a higher plane. And we also talk about how the buoyancy will affect the result. But the reporter think that is really small, so you can ignore. And the experiment setup, we talk about the ball that's going to be moving in the container. The reporter is split, and it will affect the water jet form. And we also talk about the material of the ground and the bucket. But because in the setup, so they control the material of the ground. And we also talk about the tendency of the road, whether it will affect experiment or not. And for data analysis, we talk about if the water bottle becomes 2 liters, will the data change because they're only guessing with their experiment that they just do. Thank you.
Question of viewer.
Okay, so first I would like to ask the reporter about clarify of what is actually your meniscus force that is applied on your bone. Is that a cohesive force or something?
So I think it's the pressure from the water, and also when it gets to the ground, the impact force and the pressure add up.
Okay. So next I would like to ask both of you like will the dropping angle that truly affect the phenomenon? Yes or no?
Yes. Yeah.
Yes. Okay. So what force is the main factor that in this phenomenon that you think? What kind of force?
Like the potential force that the ground gives.
And,
I think it's the pressure that the water gives to the ball. It's the water.
okay. And how do you guys think about the optimization to up to 2 liters water, which is the problem statement requirements? Under what condition can we do it?
What condition?
Yeah. Like, how can we actually optimize the height of that under 2 liters of water? Just as the problem statement said.
How do I think
Like what parameters are changed?
Oh, you mean the air pressure or something?
Yeah.
I think it's the pressure that the water gives.
Okay. So, okay, will there be boundary conditions that the phenomenon will not be formed? That's in your own opinion.
Oh, I think if it's the air pressure is not giving air. But it's no air pressure.
No air pressure. And how about
Did you ask if there will be a boundary?
boundary? That's
Nothing about.
phenomenon. No, I mean what boundary condition this phenomenon will not be formed?
I think if the air resistance is too big because the pimple is really light, then they will not reach the height that is good.
Right. Okay, so is there more factors instead of dropping height and the water volume that will affect this phenomenon?
I think the mass of the ping pong ball will also affect the experiment.
I think the radius of the container.
Okay, so if the ball is at the side of the bucket, will there be the effect about the surface tension created by the surface tension?
Yeah.
Yep. Okay, since my problem is over, let's move on.
Please, review please.
Okay, honorable juries and fellow competitors, I'm a reviewer from Team Alpha Senior High School, and today I'm going to review problem number 5, ping pong rocket. So, here will be our first overview of the reporter, where the summary of the reports are they use a camera is used in their experiments and also the fishing line for the trajectory, and also their theoretical parts, they do the force analysis of the system, and also they apply the meniscus force, and the buoyant force is not included. And for the reporter's performance, their strong points are they have clear qualitative explanation of the phenomenon, and the experimental setup is controlled for the trajectory. And about the weak points, that they didn't focus much on the problem statement's requirements, which is the optimization for 2 liters water, and the match between the theory and the experiments is unclear, and there are also lack of error analysis, which is very important in such a mechanical problem. And for a summary of the opposition, their experimental part they raised about the collision's angle, and the free bodies diagram were drawn, and also the water transformation. And for the theoretical parts, they discussed about the buoyant force and also the energy's transformation. And for the opponent's performance, their strong points are they have fluent performance, and they discuss the core mechanics such as the energy transformation with the reporter, and they give her own opinion for the optimization. And the weak points are they also didn't focusing on discussing the problem statement's requirements. And for the discussions part, the opponent asked about is there a water jet that's formed? And reporter answered there was. And our opinion is that we agree with the opponent for being jet is an important factor. And for another problem that the opponent asked about the coefficient of restitution of the ground, and the reporter's response is there is a platform that can control it, but our opinion is that we agree with the opponent that though the platform is fixed, but the coefficient of restitution still need to be considered in this phenomenon. And for next discussion about the fishing line, and the reporter's response is there is no matter. And our opinion is that we agree with the opponents that there may have deviation caused by the torque given by the fishing line. And for our own questions that we first asked about will it be the surface tension when the boat is at side, and they both answered yes, and which we also think that it will be an impact of it. And for another question is that the boundary conditions of the phenomenon, and the reporter answer for air pressure, and the opponents answer for both weights. And for our own opinion that if the height in water height in a container can form the jet, which is the core factor of this phenomenon, that there will be the boundary condition of this phenomenon. And for the force in the manufacturer, that the reporter's response for the meniscus force and the opponent response for jets, that we agree that there will be the cohesive force that leads to the jet's formation for launching, which is the another form of water hammer effect that is very important in this phenomenon. And for the optimization of the how 2 liters water can be optimized, the reporter answer for air pressure and the opponent's response for water pressure. And in our own opinion, that if the jets can be formed, which we can do the experiment about it, and it's up to the dropping heights or some variables if there is a variable. And the core point is the jet formation. And that's all of my review. Thanks for your kind attention.
Conclusion, please.
So distinguished judges and fellow competitors, and I'm going to do the review. So for the review part, this is the problem statement. So the opponent have asked me about the system that will be accurate enough, and I think the friction between the fishing line and the so we stick the straw around the container. So we think that the straw and the fishing line, the friction between them will be slight enough. So the fracture is really small. And they have asked me about whether we can make sure the ball stays in the middle or not. So we have put a three flablum in the container so we can make sure the ball is staying in the middle. And they have asked me about whether the wood in the bottom is rigid body, and my answer is yes. And the opponent have asked me about the potential energy, and I think the potential energy will be lost and changing to the kinetic energy in the end. And the reviewer has asked me about is there other factors that will impact the result. And I want to clarify that we think that the density is a significant parameters to be considered if there's another parameter to be considered. And they have asked me about if the dropping angle will influence the system, and my answer is yes. And here's my review. Thank you.
The question asked the reporter first. If you drop the ping pong ball in the top of the high H0, then the ping pong ball rebounds to high, say H1. What's the maximum ratio you can reach for H1 and H0? Okay. In all your experiments, what's the maximum ratio?
We only try to. I think the answer can be calculated in the.
Okay, in your experiments, what's your?
In my experiment.
Yeah, is the same high H, just like H0, or 2 times, 3 times, 10 times. What's the maximum?
So because the change of the height will be will be more small in the end. Well,
I just need the maximum.
maximum, like about 5 to 6 meters.
5 times stage 1. Do you understand what I mean? My question? The ratio.
Yeah, and I think it's 3 times.
3 times.
3 times.
In what condition? Oh, I mean, among the what condition means the water compared to if you're the 50% water or 20% water compared to I don't know how big the cup is.
So like in my experiment, I only put like about 80% of the water in the container.
Which is okay. How about opponent? Do you agree? What is it? He reached the maximum height about 3 times, okay, and the water is about 80%. You agree? All I mean, I believe that all of you done this experiment. So in your experiment, do you get the similar or the same result?
No, I don't get the same maximum height, and I think the difference is because the radius of the bucket.
Okay, what's the maximum?
The maximum I can get is like 2 millimeters. 2 meters. 2 meters.
2 times each now. 2 meters compared to how high?
We drop at 1 meters.
1 meter.
Yeah, we
So
do
that's
2
2
liters
times.
of water, and we do and then the ball can be launched to 2 meters.
2 meters.
Yeah.
So the how? What's the percentage? What's the percentage of field water?
I think because we use a bucket that is, I think it's pretty big, so it's like 40%.
40%.
Yeah.
How about reviewer? What's your opinion about?
For our own experiments, that can be reached to like 5.
What's yours?
But
I mean, not property.
for the condition that determining the maximum height, the reviewer thinks that it will be the air resistance which will cause the
I mean, in your experiments, what's maximum ratio you can get?
maximum ratio. So it'll like 8 times of the
8
initial
times.
jump.
You can get 8 times. So in what condition? How much the percentage of water you
Please.
It's like 1 over
percentage? 50%,
oh, like
80%,
33%.
30%.
33%
33%
of the
the
container.
water. Okay.
Yeah, it's a 2 liter of water. And if we drop at a 60 centimeter, it will fly like about 8 times.
8 times.
Please.
Thank you.
Maybe I missed something during your presentation. Did you ever mention the strategy to get the maximum height? After that's the statement when you do the strategy, the method, how to get the maximum height.
How to get to the maximum?
Yeah.
It's like we need to get the critical height when the energy dissipation is not big enough to impact the system, but the force is perfectly transformed into the ball.
I think there are 2 points discussed only superficially. One is this body shape. I don't hear much discussion about it. And the other important thing is the time that this water got ejected from the surface, or from this water surface. Because you guys all think this water jet is important. But it could be this ping pong ball already left the water surface well before this water jet start to change shape. So did you ever check the real time video, this time dimensions of this, how this water is ejected from the water surface?
Yes, in my observation, I observed that the ball will get out from the container when the container gets to the ground. So I measured and I make sure that the water it's the time that it gets to the water that the ball falls out from the container.
So this water jet is not relevant.
It's like, in my own opinion, I think that the water jet is the present of the pressure.
Thank you, please. The time is up. Marking, please. Marking time. For reviewer. No, for report. For report. Four, six. For opponent. 5, 6, 5, 7. For reviewer. Six, eight, 6, 8. Thank you all. Next stage will begin.